Welcome to Spring LIB.
Okay, so we are given this um, two half cell equations for a cell like this. E naught is equal to 1.5 volts, and then iron okay. So for the first part, we have to make a cell. So let's start by making the two anodes. So gold would be the gold anode, and iron would be preferably in platinum. And there could be a salt bridge if you want, and a voltmeter. So yeah, so we have all these things. In this case I have gold ions, and in iron I have ferrous and ferric ions, right? So in this case the electron will always travel in this direction, okay, from ferrous to ferric. Oh, sorry, from iron to gold, okay. This is the traveling. So by looking at this, I can say gold is cathode, and um, iron is anode. So to calculate E cell, I always write E cathode minus E anode, right? So cathode is gold, 1.5 minus 0.77 volts. This gives me 0.73 volts. So this has 0.73 volts. And concentrations, so at standard conditions, concentrations are equal and unity. So that means the concentration is 1 molar for gold ions as well as the ferrous and ferric ions, okay? So this was part A. Now moving to part B, it says they have provided sufficient chloride ions in gold electrode, and the E naught has now gone to 0.31. Oh, not the E naught, yeah, so E naught has gone to 0.31. So we have this equation, right? Okay, so we have to calculate K at 25 degrees, okay? So what we know is, since Cl negative is sufficient, Au plus concentration would now decrease as AuCl4 increases. So the concentration of Au3 positive is going to decrease because now we have AuCl4 present. Okay, and I'm sorry, this is actually E cell. If you look at the question again, this is E cell. So now we have E equals to E naught minus 0.0591 over N log concentration of ferrous or ferric ions. These are going to be the same over concentration of gold ion. Okay. Now gold ions is going to decrease, but the ferrous and ferric still remains the same. So after solving everything, we get this value 4.78 10 to the power minus 22. Okay, now we have to calculate the formation constant. So Kc is equal to, if you look at this equation, if you look at this equation, you have AuCl4. So this would be AuCl4 divided by Au3 positive into Cl4 4. Okay, if I substitute the values, this is going to be 1 divided by 4.78 10 to the power minus 22 multiplied by 0.1 to the power 4. So we get 4.78 into 10 to the power minus 26, which is equal to 2.09 10 to the power 25. So this is the value for K.